Relations and functions. Let's look at our definitions. A relation is a set of ordered pairs. The domain is the set of input values or x coordinates. The range is the set of output values or y coordinates. A function is a relation that assigns exactly one value in the range to each value in the domain. A function rule is an equation that describes a function. And function notation is when you use f of x to indicate the outputs. And we read it as f of x. So basically it's the outputs or the range of our relation. Let's have a look at our key concepts. Number one, we can use a vertical line test or a mapping diagram to determine whether a relation is a function. The vertical line test. If any vertical line passes through more than one point of the graph, the relation is not a function. The mapping diagram. The domain or x values must all be different numbers. The ranges or y values can be the same number. So here are some examples. Find the domain and range of each relation. Here we have a relation. It is a set of ordered pairs, and we show that it's a relation by using these braces around each end. So our set of ordered pairs or our relation is 1, 3, 4, 0, 3, 1, 0, 4, 2, 3. So in order to find the domain and the range of the relation, all we're going to do is separate those x and y values. So we know that the domain corresponds with the x values or the input values. So we're just going to list our input values. We have 1, 4, 3, 0, 2. 1, 4, 3, 0, 2. And our range values correspond with our y values or the second number in the ordered pair. So we have 3, 0, 1, 4, 3. 3, 0, 1, 4. You'll notice that 3 is repeated, and because it's repeated, we don't need to write it twice when we're listing the range values. And the same goes with the domain. So let's have a look at the second example. Our relation is 2, negative 3, negative 2, 3, 2, 3, negative 2, negative 3, 3, negative 2. So to separate our domain values and our range values, we list the values. So we have 2, negative 2, and 3. And we have negative 3, 3, and negative 2. Remember, we're not repeating any of the domain or range values that have been repeated within the relation. Determine whether each relation is a function. So here's our relation here. We have 6, 3, 5, negative 2, 2, 3, 12, negative 12. So we are going to simply list our x values and our y values, and we're going to use a mapping diagram to figure out whether each relation is a function. So our x values for this relation are 6, 5, 2, and 12, and we have them listed down here. And our y values are 3, negative 2, another 3 that's been repeated, and negative 12. Now we don't need to write the 3 twice, so we just list 3, negative 2, and 12. And then we just simply match them up according to where they correspond with. So our 6 corresponds with 3, our 5 is paired up with negative 2, our 2 is paired up with 3, and our 12 is paired up with negative 12. So because each of these x values or these input values or the domain values have only been assigned one y value, then yes, this relation is a function. Over here we have another relation, 3, 7, 2, 5, 1, 6, 3, negative 5. So in order to determine whether it is a function, we're going to go ahead and list our x and y values. So our x values are 3, 2, and 1. We have a repeat of 3. We don't need to list that again, but that should be a clue. And then we have our y values. We have 7, 5, 6, and negative 5. 7, 5, 6, and negative 5. So we're simply going to match them up with the number that they correspond with in the ordered pair. So we have 3 with 7, we have 2 with 5, 1 goes with 6, and 3 goes with -5. So this should be a big clue here, as well as the fact that we have 2 domain values that are the same. Because this domain value or the x value or the input value has been assigned 2 range values or 2 y values or 2 output values, then no, this relation is not a function. Use the vertical line test to determine whether each graph is the graph of a function. So imagine we have plotted our relation or our set of ordered pairs onto a graph. Now we can look at the graph and see whether or not it is in fact a function. So what we're going to do is we are going to get a vertical line. It could be a pencil or a ruler or an imaginary vertical line. And we're going to run that across the graph horizontally. And if that vertical line passes through 2 points in the graph at the same point along the graph, then no, it's not going to be a function. So let's have a look. If we run our pencil along this graph here, the green line, then it's only ever hitting 1 point on the green line. So yes, that is a function. Over in number 2, if we run our vertical line across, you can see that it's hitting here and here in the graph at the same time. And that continues as we go across the graph. So because our vertical line is hitting more than 1 point on the graph as it goes across, that means that this is not a function. Similarly, in number 3, it starts off pretty good. We're only hitting 1 point on the graph. Keep going. And then we get to this point where we are hitting many points on the graph. And so because we're hitting more than 1 point on the graph as our vertical line goes across, that means that this is not a function. Number 4, as we run our vertical line across the graph, you can see that it is only passing through one part of the graph at a time. So that means that this is a function. Evaluating function rules. So if we are evaluating f of n, now remember we could have f of x, we could have f of n, we could have g of n. It's just, there are really a lot of ways to represent function notation. So evaluating means to solve out. So if we were to evaluate f of n for f of n equals -3n minus 10 for n equals 6. Basically, all that means is that they're giving us a value for the n, and we are going to plug that in to the function of n. So let's go ahead and follow that through. So f of n equals -3n minus 10. So we're going to go ahead and plug in 6 wherever we see n. So f of 6 equals -3 times 6 minus 10. -3 times 6 is -18, minus 10 is -28. So f of 6 for f of n equals -3n minus 10, f of 6 equals -28. Over here we have evaluate y equals -2x squared plus 7. This y here is just another way of writing f of n or f of x. It's just another function notation. So y equals -2x squared plus 7 for x equals -4. So anywhere we see x in the equation, we're going to plug in -4. So y equals -2x squared plus 7. Here's the x, we're going to plug in -4 instead. -2 times -4 squared plus 7. Using our order of operations, we're going to do the parentheses and the exponent first. So -4 squared is 16. So -2 times 16 plus 7 equals -32 plus 7, which equals -25. So let's have a look over here. We're going to evaluate g of x, which is just another form of function notation. G of x equals negative x plus 2 for x equals negative 3. So anytime we see x, we're going to plug in negative 3. So g of x equals negative x plus 2. We're going to plug in negative 3. G of negative 3 equals negative 3, and we can plug in a 1 there. It's like negative 1 times x plus 2, which equals negative 1 times negative 3 is 3 plus 2, which equals 5. So g of negative 3 equals 5. Finding the range of function rules. Find the range of each function for the given domain. So the given domain is negative 2, 0, and 5. They are our input values or our domain values or our x values. And we are going to be given a function that we need to work out the range values for the domain values that we have been given. So our first function is f of x equals x minus 6. So anytime we see x, we're going to plug in the values. And we'll start with negative 2. So f of negative 2 equals negative 2 times negative 6, which equals, negative 2 minus 6, which equals negative 8. Then we're going to go ahead and plug in the next domain value, which is 0. So f of 0 equals 0 minus 6, which equals negative 6. The next domain value is 5, so let's plug that in. F of 5 equals 5 minus 6, which equals negative 1. So our range values for this function, for this given domain, is negative 8, negative 6, negative 1. Let's have a look at number 2. Y equals negative 4x. So using this function and this given domain, we're going to find the range values. So let's go ahead and plug in our first domain value, which is negative 2. Y equals negative 4 times negative 2, which equals 8. And then we're going to plug in the second value, which is 0. Y equals negative 4 times 0, which is 0. And the third value is 5, so y equals negative 4 times 5, which is negative 20. So our range values for this domain value using this function are 8, 0, 20. Negative 20. So let's go ahead and do number 3. We have g of t equals t squared plus 1. So we are going to go ahead and plug in these values to find the range values of this function. So let's start with negative 2. G of negative 2 equals negative 2 squared plus 1. So g of negative 2 equals negative 2 squared is 4 plus 1 equals 5. Let's go ahead and plug in g of 0. G of 0 equals 0 squared plus 1. 0 squared is 0, plus 1 is 1. Let's go ahead and plug in the third domain value, which is 5. G of 5 equals 5 squared plus 1. 5 squared is 25, plus 1 is 26. So our range values for the given domain, negative 2, 0, and 5, for the function g of t equals t squared plus 1 is 5, 1, and 26.